Going on, guys? In this video we are going to see how to solve a differential equation with the Laplace transform. But before we do that, we have to know some stuff. Like these are some reminders. Like when we have a function with second derivative, when we convert this one into s world, this is going to turn into s square f of s minus s f of 0 minus f prime of 0. And when we convert the first derivative of a function from here to s world, it's going to become s f of s minus f of 0. And also when we have t power something, e power some power, when we convert this one into s world, it's going to become like this. Okay, so this is Laplace transform, and here we have inverse transform. We will do that one at last part. Okay, now let's do this, like let's look at this one through this example. Here we have a differential equation. We are going to first convert this one into s world. Now here you can see when we have f double prime, that turn into s square f of s, s f 0, f prime 0. Here we have y double prime. So when we turn this one into this kind of pattern, this is going to become s square. Since we have y, here we have, when we have small f, we put capital F, right? So when we have small y, we put a capital Y. So s square capital Y of s minus s f of 0. F of 0 is, in our case, y of 0, right? Y of 0 is provided, so we can directly write that one, negative 1 right here. Then minus f prime of 0, that is y prime of 0 in our case, that's going to be just 6, so we can plug 6 right here. So this is for the first part, right? Y double prime. Now let's use a different color to put the other second one. In the second one we have 6y prime. So when we have f prime of t, when we convert this one into s world, it's going to become like this. We are going to have s f of s. So in our case we are going to have 6 in front, and y prime is going to turn into s capital Y of s, s capital Y of s, and we have to have minus f of 0. In our case y of 0 is negative 1, so negative negative 1, that's going to make this one positive 1. Okay, so now we have converted these two, and when we convert this 9y into s world, that's going to become just plus 9 capital Y of s, and that's it. And in the other side of the equation we have 0, so we equate this one to 0. Now let's try to bring all the Y of s terms together. Okay, so here we are going to have, okay, let's use a different color maybe. Okay, let's use 0. So here we have s square Y of s. Let's write this one right here. And here we have 6 times s y of s. So before I do that, it's better to simplify this one first. This is going to become s times minus 1. That's going to become plus s. Plus s. Here we're going to have minus 6 plus 6 s y of s. And plus 1, 6 times plus 1, that's going to be plus 6. And here we have plus 9 y of s is equal to 0. From this one, let's cancel everything we can cancel. Minus 6 plus 6 cancels. And if you look at this y of s terms, here we have y of s, here we have y of s, here we have y of s, right? So let's bring these three together. So this is going to become s square y of s, and after that here we have 6s y of s, 6s y of s, and here we have 9 of y of s, y of s, and here we have s. So what I'm going to do with x is I'm going to bring this s to the other side of the equation. So if I do that, this is going to become negative s, right? That's the only other term we have. We don't have anything else, and this is equal to this. If we take y of s common, this is going to become s square plus 6s plus 9, that's equal to negative s. And from this one you can see this is a perfect square trinomial. This is a s plus 3 whole square, right? So I'm going to bring this one to the other side and write this one down. Y of s is going to be equal to negative s over s plus 3 whole square. Now we have to think about how can we convert this one into some of this pattern, because we have to convert this one into like t world. So in order to do that, we have to have some pattern like it's 1 over s minus a, or we have to have some number over s minus a, something like that. Here we have negative s. So what we can, first thing we can do is we can move this negative to the front. Let's set different color. Okay, if we move the negative to the front, we are going to have Laplace. Okay, here we are going to do the inverse Laplace transform. So this is y of s, and I'm going to write y of t right now, because when we do the inverse Laplace transform, all this s world will turn into t world. So here we are going to do the inverse Laplace transform, but before I do that, I move this negative sign to the front. Negative sign to the front. So we are going to have negative Laplace inverse, and here we have s over s plus 3 whole square, right? So still it's not matching any pattern right here. So to make this one match this pattern, what we can do is we can add a 3 and subtract the 3. The reason is because I can separate this one into two equations, like minus Laplace inverse. I keep this s plus 3 right here, s plus 3 square, and I can separate this minus 3 and write another equation like minus 3 minus 3, and the denominator is going to remain the same. That's going to be s plus 3 whole square. Okay, in the first one if you notice, here we have s plus 3 in the numerator, and the square will cancel, so we get 1 over s plus 3. That is matching this e power at pattern, because we have to have 1 over s minus minus a. To write this one in that pattern, what we do is we put l minus a, and this is going to be 1 over s minus minus 3, and now you can see the pattern. For the first one we can change it, right? For the second one, let's see, here we have s minus, this is almost matching this pattern, s minus a n plus 1, right? So we have to have 1 in order to be, we have to have the 1 in the numerator. Here we have power 2, we have to have the 1 in the numerator. To make this one 1, we can move this 3 to the front and just keep the 1 right here. So this will become less than 1 power, because we had to have 1 factorial in order to convert this one into second pattern. Okay, so this is going to be 3 over s minus minus 3 whole square, and this is actually 1 factorial. 1 factorial is basically 1, so we can just keep it like this. Okay, now we have converted this one into this kind of pattern, so we can now write everything in terms of t. First we have to know what is our a value, and in our case, in the first one, our a value is the value we are subtracting, that is negative 3. So let's note that one down. A is equal to negative 3 in the first one. Let's write somewhere here, a is equal to negative 3. So when we convert this one into here, like we are using the first one, e power, and also we have negative sign in front, e power negative a times t. A is negative 3, so negative negative, that's going to be positive, so we are going to have positive 3t. Okay, this is for the first one. Okay, let me make sure a is negative 3. We just put negative 3 because a times t, a is negative 3, negative 3t, and then we have minus, and then 3, 1 over s minus minus 3 whole square, that is matching the second pattern, right? And in our case, n is going to be 1, so this is going to be just t right here, because we had t power n when we convert this one into t world. So t power n is 1 less power than this power, so that's just 1. And e power at, a is 3, a is negative 3 here also, so a is negative 3, so this is going to be e power negative 3t. Now I can combine this minus and this minus, make this one plus. Okay, and yeah, this minus is yeah, you have to make sure this minus is multiplication of everything. So this one is definitely going to be plus, because I should have put like this, a bracket like this. So if I remove the bracket, this is going to become positive. Okay, so this is going to be minus e power 3t and plus 3t e power negative 3t, and that's how we solve a differential equation using Laplace transform. I hope this helps. Thanks for watching.